Thank you. I begin my presentation with a slide of the lower part of a life-size statue. Those of you who are fans of ancient Near Eastern art will recognize this famous bronze or copper statue at the National Museum in Baghdad. This is one of the countless artifacts that were looted or damaged in April 2003. The National Library was looted shortly thereafter, leaving those of us who study and admire these ancient artifacts in a state of shock. The reason I bring this statue up is because I recently received an email from MESA, the Middle East Studies Association, regarding what they term the cultural genocide in Gaza, where very few ancient or medieval buildings have been left standing, compounding the unspeakable humanitarian crisis. Many of us who work or have studied in this field have relatives in the Middle East, and the reality of having family members in the crosshairs of guns and of missiles is ghastly enough. The same crosshairs are often trained on cultural artifacts that are then obliterated, lost to the forces of chaos. I turn to my presentation of Shirazi mindful of all that was lost in just the past 5 months, both in terms of the tragedy of human victims, the dead, the wounded, the suffering, and the starving, and the cultural artifacts as part of our common heritage that have been lost forever. The topic for today's talk is Quṭb al-Dīn Shīrāzī. These are his dates. He is often credited, if that word can be used, as being the most famous student of Nasiruddin Tusi. He composed works on various topics. Most notably for us today are 3 relatively lengthy tomes on the subject of Hay'a, or the configuration of the orbs. Subsequent Islamic authors were interested in Shirazi's Hay'a compositions, and each of these works survives in numerous manuscript copies. The interest of modern scholarship has often focused on Shirazi's modeling of planetary motions, i.e. the motions of Mercury, Venus, the Sun, the Moon, Mars, Jupiter, and Saturn, the so-called wandering planets that have mesmerized observers since prehistoric times, and which, among other things, give us the 7 days of the week. Looking at the date of publication, we see that these were composed in a relatively short period, raising the question of what Shirazi's possible motives could have been to write 3 largely similar works. One distinction between the 3 is the language that Shirazi chose to compose his works in. The first and the last, Nihāyat al-idrāk, dirāyat al-aflāk, the limits of attainment in the understanding of the orbs, and al-tuhfa al-shahiyya, the royal offering, these were in Arabic. Ikhtiyārāt-i muẓaffarī, however, was in Persian. Shirazi includes biographical information in his own al-tuhfa al-sa'diyya, a commentary on the kulliyat, i.e. the first book of the canon by Ibn Sina, containing written roughly during the same era as the astronomical works. He also writes of his life in al-Durrat al-Taj li-Qurrat al-Dabaj, an encyclopedic work written near the end of his life. And this work is often humorously referred to in Persian as Ambane Mullah, or the sack, the storage bag of the mullah. So viewed rather humorously as a somewhat pedantic work. Of the authors who mentioned Shirazi, Ibn al-Fawati is the most important by virtue of the fact that he was a contemporary of Shirazi and knew him personally. Ibn al-Fawati was the first librarian at the fabled Maragha Observatory in what is northwest Iran today, slightly south of Tabriz, and almost certainly that is where he met Shirazi. Sadly, the original work by Ibn al-Fawati is lost. What survives, entitled Majma' al-Adab, a convocation of culture, is the abridgment of the original. But much of the material found in the other works listed on the slide is most likely from Ibn al-Fawati's original biographical dictionary. In Durrat al-Taj, Shirazi writes, "I was from a household that was famed in this art, i.e. the art of medicine, by virtue of my family's success in the treatment and correction of the humors, with Jesus-like breaths and Moses-like hands. I, too, rejoiced in the bloom of my youth in attaining this art and comprehending it in detail and in generalities. And I engage in all that was associated with medicine and with ophthalmology, as far as hands-on techniques." And here he lists a number of surgical techniques that he engaged in. All of this I did beside my father, Imam Ziauddin Mas'ud al-Muslih al-Qaziruni, who was considered to be the Hippocrates of his age and the Galen of his day. He continues, since I had developed a reputation, I was made physician and ophthalmologist at the Muẓaffarī hospital in Shīrāz after the death of my father when I was 14 years old. And I stayed there for 10 years as one of the doctors who would not desist from studying except when providing treatment. This is because my soul was not satisfied, and rather it drove me to exert my utmost and to attain the highest level of achievement. Ibn al-Fawati, his biography, takes up the narrative here. He says, Shirazi arrived in Maragha in the presence of our guide and master Nasir-ad-Din Tusi in the year 658. That's 1259 or 1260 CE. And he studied mathematics with Tusi and studied with Najm al-Din al-Quṭb, his compositions on logic, and studied with Mu'ayyid al-Urdi, which he had composed on astronomy and geometry. Shirazi writes of the same period, I turned my attention to that city of knowledge and that Kaaba of wisdom. May God sanctify his soul and bless his resting place, so that some of the obscure points were clarified. And he's referring now to Ibn Sina's canon on medicine, with other points remaining obscure. This is because a mastery of theoretical principles is not sufficient for the comprehension of this book, meaning the canon. Rather, it is necessary, in addition, for the person to be a practiced physician with experience in the principles of therapy. I add this bit this fragment from Shirazi to highlight the fact that he considered the pursuit of medical knowledge as one of his lifelong goals. And he, in fact, there's a slight criticism here of Tusi for not being a practicing physician. Looking at the chronology of Shirazi's life, we note that when he met Tusi, Tusi at this point was one of the highest ranking courtiers at the Ilkhanid court, which had been established circa 1257 by Genghis Khan's grandson, Hulagu Khan. We know that Tusi was the first director of the Maragha Observatory, implying that Shirazi had managed to whisk himself from Shīrāz to the center of political power in Persia. Here, Shirazi's account loses its detail as he talks about his search for commentaries on the canon all the way from Khorasan to Rum or Anatolia, with his search remaining unfulfilled until his appointment. He is appointed as an emissary to the Mamluk court in Cairo, where he finally achieves his heart's desire in getting his commentaries. We know from other biographical sources, however, that Shirazi spent time in Anatolia, and he spent time in Sivas, where he was a judge. This was the capital city of the Seljuks of Rum, a client state of the Ilkhans. Judging from the world-class architecture that survives even today in Sivas and nearby sites, the Seljuk court would have been a truly opulent experience for Shirazi. Indeed, it was in Sivas in which Shirazi wrote the astronomical text that he is most famous for. Before we get to those, we conclude Shirazi's biography by noting that he died in Tabriz and was buried there after a lavish burial ceremony. So here I have a map. This is Shirazi's birthplace. This is where he relocated to meet Tusi and to study with the intellectual luminaries of his era. And then he ended up going all the way to maybe to Qa'in, Khorasan, and then to Rum, Anatolia, to look for more books. And he ended up in Sivas as a judge, where he composed his astronomical texts. As a learned man known as Allameh in his own lifetime, Quṭb al-Dīn wrote on other topics as well. His commentary on Sohrawardi's Hikmat al-Ishraq was well known. In Shirazi's astronomical work, he collected mathematical formulations due to Tusi and Urdi and added them to formulations that had already appeared in the Almagest and termed these usul, or principles. So that's one of the main structural components of his Hay'a compositions. Shirazi was the first author to compile in a single work the innovative mathematical formulations meant to rid the Ptolemaic description of the planetary orbs of their flaws. These are primarily the Tusi couple and Ordi's lemma. So here we have a map of the Ptolemaic cosmos. We have a view of the nested spheres. There are 9 celestial spheres, 7 for the wandering planets, and an orb of the fixed stars, together with an orb of orbs, that's the 9th orb. All Heya compositions contain this conception of the universe, which already appears in Ptolemy's planetary hypotheses, which was a short tract composed by Ptolemy subsequent to the Almagest. It is not indeed unusual for Heya texts to estimate the size of the universe by adding the thickness of the shells together. The absence of a vacuum was a central Aristotelian tenet held by Shirazi and his fellow Heya authors, and this meant that if you knew the thickness of these shells, you just added them together, since a vacuum was forbidden, and you could compute the radius of the universe. Another tenet held by Shirazi and his fellow Heya authors was the notion that celestial objects could only move in what we'd call today as a uniform circular motion. In this map, I don't have the sublunar realm, but the sublunar world, which is the circle really beneath that of the moon, the orb, that contained its own spheres. The outermost was a sphere of fire, which encased, in turn, the spheres of air, of water, and of earth. And the celestial world, which was all the orbs that you see in this picture, was thought to be composed of a 5th form of matter, namely ether. Each of the 7 celestial spheres, or aflāk, pertaining to the wandering planets depicted in the previous slide, contained its own machinery that was based squarely on the formulations of Ptolemy in the Almagest. In the Islamic conception of the system, the notion of orbs, either spheres or spherical shells, was central. So the physicality of the orbs was a centrally held belief. This was not observed in Ptolemy's original masterpiece, the Almagest, and there's more of a physical notion of the universe in planetary hypotheses. Here we see a standard rendition of the orbs of the sun. So we see the center of the universe, and we see that the sun is rotating in a deferent. So the 6 circles are supposed to represent the body of the sun itself in this case, but it is displaced relative to the center of the universe because in order to account for observations involving the length of the seasons, for instance. Ptolemy had already noted that the configuration due to Apollonius, consisting of 2 uniform circular motions, could achieve the same circular orbit. So here we have if you like, a vector ke rotating with a uniform counterclockwise angular velocity, and then an el is rotating with a clockwise rotation. And if you add the 2 vectors, the result is going to be a displaced circle. So this was something that Ptolemy had already listed. But this appears to have been an impetus for, especially for Shīrāzī, to collect similar conceptualizations that could lead to explaining the planetary motions. So in other words, since everything had to be circular, it was all right to have vectors, as in this case, to be displaced from the center of the universe, provided they rotated in uniform circular motion. And here we have, again, the sun. Sorry, I have to move a control bar. Let me see if I can do it. Yeah, there we go. So the Heya compositions, such as Shīrāzī's, were based principally on 2 compositions by Ptolemy, the Almagest, and planetary hypotheses. Shīrāzī appears to have conceptualized the formulations by Tusi and al-Ordi as elements of a toolkit meant to rid Ptolemaic astronomy of its inconsistencies. This toolkit contains some formulations that appear already in the Almagest, most notably the formulation due to Apollonius, which we just saw a moment ago. Right. Now, let's see. So slides, please bear with me as I try to advance my slides. Sorry, there's a technical issue maybe. Hold on just. Okay, well, I'm going to temporarily stop sharing. Just let's see, let's share one more time.
In the meantime, I encourage everyone to post questions in the Q&A.
All right, let's see. So yes, so here we have the Tusi couple, right? Again, so this is the celebrated Tusi couple that we can see basically two vectors. There's vector AB that's rotating clockwise with the angular velocity theta or theta prime, if you would, and then there's a vector BG that's rotating counterclockwise at twice the angular frequency. And the resulting motion, if you look at the point G oscillates back and forth on that straight line, that vertical diameter. So this is the celebrated Tusi couple. And Tusi was able to use this in his lunar model to try to address the irregularities that or the inconsistencies within Ptolemaic model. Here's a picture. This is a picture from one of Tusi's compositions in Arabic, al-Tadhkirah fi ilm al-Hay'a, the memoir on astronomy. You can see he has 4 depictions of his couple in this figure. This is an earlier text, Risale Mo'iniyeh, and it's in Persian, and you can see that this same Tusi couple is depicted in these figures. The other innovation that Shirazi could benefit from in his modeling was due to al-Orti. And here we see vector KE is rotating, with theta in the counterclockwise direction, and EL is also rotating with the same angular frequency, and the dimensions LE and KB are the same. And if you input the parameters for the solar system, that point L hugs very closely the circular orbit, but it benefits from the fact that it's the sum of 2 uniform circular motions. And this is something that the scientists of the Hay'a tradition were after. So these are the orbs of the moon, considerably more complicated than that of the sun. This is the common rendition of the orbs of the moon due to Ptolemy, and it's embedded in the spheres that the Islamic authors considered essential. It is considerably more complicated, as we said. We see that the moon is now carried on an epicycle. These are the six smaller circles, and you can see the dark circle of the moon, so considerably more complicated. In this case, the moon moves in a circular orbit around the deferent center that's marked. Its speed, however, the speed by which it rotates on this circular arc is not uniform. Rather, it appears uniform to an observer at the center of the universe. And this is something that the authors of the Hay'a tradition were upset about. To add insult to injury, Ptolemy had also to define an alignment point. We see the alignment point at the bottom there, in the middle of the figure, that was equidistant from the center of the universe, but in the opposite direction. This allowed him to have his theory for the location of the moon on the epicycle itself to agree with observations. So first he had to place the center of the epicycle, and he had to resort to this notion of a variable speed on a circular orbit. But then in addition to that, he had to refine his model and say, well, I'm going to have to select a prescribed diameter on the epicycle. This diameter is defined by the alignment point. In this case, the line drawn from the alignment point to the center of the epicycle defines a time-dependent point of origin relative to which the phase or argument of the moon has to be calculated. So it's of course a masterpiece in scientific writing, but as far as the notion of uniformly rotating spheres, it had issues. And so we go back just to the sun here to remind ourselves that the sun was considerably simpler, and but there were both in the Islamic tradition, conceived in the sense of having orbs spinning around in uniform. Well, in this case, they would have been non-uniform because of the Ptolemaic rendition. All right. Now, I would like to share for you a correspondence of Nasiruddin and Tusi, just highlighting the fact that the concept of the orbs was central. So, Asiruddin al-Abhari, sorry, Abhari. He was a contemporary. He was active in northern Iraq. He was presumably from Abhar near Zanjan, but we see every circle. This is Tusi's letter, which has been preserved as a matter of style, epistolary style, thankfully, but we don't have the response of Abhari. Tusi says, every circle carrying another circle on its perimeter, when set spinning in place in uniform motion, thus moving the carried circle through the rotational motion of the center of the deferent, would require the following three things: the equality of the resulting angles on its perimeter, the constancy of the distance between it and the center of the deferent, the persistence of a prescribed diameter as far as alignment. But we see Abhari himself in a different work. You know, he has a slightly different view, and the roots of this argument really go back to classical times, to Ptolemy itself, right? What was the significance of these formulations, and what was the nature of the orbs? So Abhari says, there are those that render the epicycle for the superior planets as consisting of three encompassing orbs, with each having distinct poles and motions, while rendering the epicycle for each of the inferior planets as composed of 5 orbs of different motion. Some of these affairs are not certain, for it is possible that the motions of the orbs are on circles, not on spheres. It is possible that they are on spheres consisting of spheres with uniform motion. It is possible that the motion of the sun occurs on an epicycle with its center moved by the motion of another concentric orb. It is not within the power of human thought to truly comprehend the manner of the heavens, right? So here we have an opposing point of view, you know. What is the true significance, the physical significance of the mathematical formulations that allow us to predict the motions, the planetary motions? But this is a picture of Tusi stipulations. Just we have a deferent, we have the epicycle, the smaller circle, and basically he says, you know, if this is uniform circular motion, then the center of the epicycle needs to sweep out equal arcs in equal times, and it needs to be equidistant from the center of the deferent, and that the diameter that's aligned with the center of the deferent has to remain the same. So clearly, this was meant as a criticism of the Ptolemaic system. Here's the Ptolemaic lunar model. Let's see, do we have text for that? So this is, as we said earlier, the center of the moon's epicycle is moving on that circle, but the circle itself, but it's not moving uniformly. It's not moving uniformly. And Shirazi, to his credit, was able to come up, by hooking up Urdi's lemma, he was able to come up with 2 uniform circular motions that would place the center of the moon's epicycle pretty close to where Ptolemy expected it to be based on his observations. So this is Shirazi's lunar model. It already appears in the first book, the Nihāyat al-idrāk, and the second book, Ikhtiyārāt-i muẓaffarī. Even though this fact was not immediately obvious when people looked at Shīrāzī, they thought that this had only appeared in Tusi's work. But you can see there's an Urdi's lemma at work here. Shīrāzī has moved the center of his deferent from A to K, but he's added an extra epicycle. And you see point S is very close to point C. So even though S does not trace a perfect circle, that's irrelevant. It's the sum of 2 uniform circular motions, and it matches the observations very well. So this is one of Shirazi's successes. This is one of Shirazi's great successes. Now, if we look at Shirazi's Nihāyat al-idrāk, one thing we notice about the book are the extensive revisions, right? You know, there are places that have been crossed out, and indeed, there's even more interesting to me, and I mentioned this in my Shirazi book. This manuscript, incidentally, is in Istanbul, but you can see, yes, you can see in the same page, you can see that he's inserted a law, a negation. So, after working things over quite extensively, at the end, he's been forced to insert a law negating everything he's done. So it's a quite remarkable book, but it also highlights the fact that Shirazi was prone to publish his work before it was ready, because this is an early copy of Nihāyat. And it's a rather unexpected feature for this figure, for this scientific figure. So if we look at the chronology of the Nihāyat works, we see Nihāyat al-idrāk, and let's see, what did I want to say about this was that these were really written in very close succession, and they really offer an opportunity for the researcher to look at the process of model building. Certainly, Shirazi had certain ability in model building. He was able to produce a model of the moon using Urdi's lemma, in a sense, simplifying what Urdi himself had done. A simpler solution had eluded the mathematician, the great Urdi, who had come up with Urdi's lemma, but Shirazi was able to hook things up just right to get a working model. And then if you look at these models, they really offer a window into this process. And we saw an image of Nihāyat al-idrāk fi dirāyat al-aflāk, where the pages are heavily worked over as Shirazi is trying to come up with a working model. Now, one of the privileges in my life was studying with George Saliba at Columbia University, and along with Edward Kennedy, of course, who was his mentor and teacher. He's one of the founding members or the founders of this field, right? And there's an essay that was published in '98 by George Saliba entitled "Persian Scientists in the Islamic World." I bring up this essay due to the fact that I would like to look at the reception of astronomical works by Shirazi. This reception in the West is instructive. Writing in the mid-60s, Edward Kennedy only knew two of Shirazi's Nihāyat works. These are Nihāyat al-idrāk and Tuhfa al-Shāhiyya. He did not know the Persian work. Kennedy's interest in these works stemmed from the fact that both Urdi's lemma and the Tusi couple appear in the works of Copernicus, and thus this raised the question of scientific transmission from the Islamic world to early modern Europe. Kennedy attributed Urdi's lemma provisionally to Shirazi, though noting as well the lack of certainty regarding the authorship. Remember that Urdi was one of Shirazi's early astronomy instructors when he moved to Morocco. Imagine what a privilege that would have been. It was George Saliba who was able to attribute this formulation properly to al-Urdi with his research. Saliba knew of Ikhtiyārāt-i muẓaffarī, but he assigns an arbitrarily late date based on the somewhat circular reasoning that Persian Nihāyat works would necessarily be abridgments or translations of works written in Arabic. And that, in my view, that's an oversimplification. In my own work, I was able to question the chronology, meaning this was before a firm dating for Ikhtiyārāt was available. And I noted that there was a passage regarding the alignment point that appears in, or that is referenced in Nihāyat al-idrāk, right? So Shirazi says, if you want to look at this, why don't you study Ikhtiyārāt-i muẓaffarī? And to me, this act of cross-referencing suggested that Ikhtiyārāt could not be of a very late date, that the production of Ikhtiyārāt was probably very close to the Nihāyat, and indeed a dated copy was discovered by Amir Gamini, who has steadfastly worked on Shirazi in Tehran now for over a decade, and so this date was able to be confirmed. The fact that the two works were completed in close succession, as I mentioned, was confirmed by Dr. Gamini. In this same essay that in a different essay, I should say, I apologize, Saliba attributed Shirazi's successful model for the Lunar Epicycle Center to Shirazi's third work, whereas I was able to find essentially the same model in the two earlier works, namely Nihāyat al-idrāk and Ikhtiyārāt-i muẓaffarī. All this to say that a great deal of work remains to be done if we are to understand the significance of Shirazi's contributions in relation to other authors of the Nihāyat tradition. This is just a list of texts that were written on Heya. Some of them are indeed translations of Arabic texts, but you can see that the list stretches. If we look at Marwazi's Kehan Shenakh, stretches by almost 2 centuries prior to Shirazi's Ikhtiyārāt-i muẓaffarī. And all of these works, some of these have been published, but many of them are languishing for lack of attention. One of the works that was recently published, this is Ikhtiyārāt-i muẓaffarī, was published last year by Amir Yamini, who again has worked painstakingly to publish this work on Shīrāzī. So just to recap, Heya was based principally on 2 compositions by Ptolemy, the Almagest and planetary hypothesis. Shīrāzī, though having his drawbacks as a theoretical astronomer, appears to have conceptualized the formulations by Tusi and al-Urdi as elements of a toolkit meant to rid Ptolemaic astronomy of its inconsistencies. Now, this goes to Shīrāzī's commentary regarding the alignment point. We see that in order to get his model to predict the proper position of the moon on the epicycle, Ptolemy had to define an alignment point, which defined then this diameter PH, or this line PH, which was a moving origin relative to which the argument for the moon had to be computed. And of course, this was very upsetting to people like Shīrāzī and Tusi. So Shīrāzī has this figure in the Ikhtiyārāt. And, when I was working on this for my PhD, I basically looked at this and I thought, oh, this is something I'm going to have to look at later. It must contain great wisdom. However, with Shīrāzī, often one is surprised. Here, Shīrāzī writes, this is Shīrāzī in Ikhtiyārāt. He says, the point that is selected as the origin for the motion of the epicycle, in this case, we're looking at, this would be point N in the figure, right? Is none other than the endpoints of the diameter that is aligned with the point about which the motion of the epicycle center is uniform, and the existence of such a diameter is necessary in this case, for whenever the motion of the epicycle is uniform about a point, it is necessary that a specified diameter always be aligned with that point. So this echoes Tusi's missive to Abhari, but Shīrāzī is using this as a geometric proof and failing rather spectacularly. Shīrāzī adds, and this holds if this point is not the center of the orbit of the epicycle, as is the case with the moon, since the center of the world is not the center of its orbit, right? The center of the world is essentially, it's the point about which the moon executes uniform motion. Shīrāzī adds, this is either because it is drawing near and far from it, or because the moon does not actually possess a true orbit, meaning that it does not move along a true circle. So it is relatively easy to look at that statement and be reminded of the Tusi couple and Urdi's lemma, which Shīrāzī clearly was comfortable using. But referring to them in this context is extremely confusing well, it was when I first saw it, and I was able to look at Amir Yamini's work, and he was also astonished that this text was in Ikhtiyārāt. If you look at the commentary by Amir Yamini. Shīrāzī proceeds, and for the purpose of facilitating the visualization of it, and for clarity, we imagine that A is the center of the world, B is the center of the epicycle at the apogee. So due to the fact that the center of the world and the center of the epicycle and the point that is the intersection between the perimeter of the equant, which is the big circle, and its radius are always collinear, so AD is always superimposed on AB and never separate from it. So I can actually continue reading this text, but Shīrāzī, it's not actually a geometrical proof. It's rather a one that's rooted in Shīrāzī's conception of spheres and what they should be doing. Shīrāzī concludes his discussion by a self-congratulatory note that is mystifying, as his argument does not constitute any sort of proof. It is rather a conceptual description of how an epicycle could rotate uniformly about a point while drawing near and moving away. What is particularly mystifying is how Shīrāzī proceeds to reference the Almagest, Book 5, Section 6, and Ptolemy's painstaking calculation in arriving at the correction for the motion of the moon, which necessitates the alignment point. He actually alludes to the correct sections or to the correct values, the correct angular values. But he concludes his discussion by citing the possibility of observational error in Ptolemy's derivation, leading the reader to wonder if Shirazi was directing his work at all to technically educated readers. Shirazi's approach with regard to the alignment point was criticized by the 14th century astronomer Sadr al-Sharia, who wrote regarding Shirazi's Tuhfa, the third book in the set, that Shirazi had spoken at length about the alignment point without any apparent success. Shirazi is known to have been responsible for other ill-conceived formulations, such as his planetary models for the superior planets, and I will be concluding in about a minute, as these appear in Nihāyat al-idrāk and the Ikhtiyārāt. Unlike these models, which were revised in the Tuhfa, the third work, Shirazi's conceptualization of the alignment point, the one we're looking at, did not appear to be the subject of reconsideration and appears in al-Tuhfa as can be seen by Sadr al-Sharia's criticism. So we've seen this correspondence already, so I'm going to go to my themes, right? So the period of 1281, 1285, these were bursts of productivity for Shirazi. His AI compositions are marked by innovative modeling based on earlier research of Tusi and al-Ordi. This is particularly notable in the lunar model, and he's also credited for a successful model for Mercury, which had eluded Tusi, for instance. Shirazi was able to successfully apply al-Ordi's lemma for the lunar model, for instance, even though this appears to have eluded al-Ordi himself. Shirazi's writing is unstable. We saw Nihāyat al-idrāk was heavily revised and of uneven quality, as can be seen by his unsuccessful attempt at solving the alignment problem. Like Tusi, but not other contemporaries such as Abhari, Shirazi was fully invested in the notion of the physicality of the orbs that would, when linked together as rotating as a group, would produce, sorry for the typo, the complicated planetary motion that can be observed by observers. And here are my concluding remarks. Shirazi's statements regarding the alignment point for the moon, as they appear in Ikhtiyārāt muẓaffarī, are a puzzling instance of Shirazi claiming to produce a substitute theory to Ptolemy while failing to do so, rather spectacularly. Given Shirazi's apparent skill in linking various combinations of the formulations of Tusi and al-Ordi to solve other problems within the Ptolemaic theory, the source of Shirazi's blunder remains unexplained and must await further research. And Shirazi's work and the research that has been done so far on them highlights the collaborative and incremental nature of the study of this key figure and of the other scientists of the Islamic world. I thank you for your attention, and I'm going to leave with the Basetki statue here to ponder the fate of these artifacts that we all admire and love to study. Thank you again.
Thank you very much, Dr. Niazi, for a wonderful talk. We have received a number of questions, and I encourage you to ask more, post more questions in the Q&A as well. So I'll start by the first question. Do we have sources that discuss the astronomical teaching syllabuses at the Marqa Observatory?
That's an excellent question, of course. The Marqa Observatory is notable by virtue of the fact that not only was Hulagu's project the assembly of the most well-known astronomers of his age far and wide, all the way from China and indeed from Syria and other parts of Persia, but that when he conquered Baghdad, for instance, in 1258, that the books that survived were hauled to Maragha. So it had a huge library available to the researchers. Ibn al-Fawati was a librarian. As far as the syllabus, unfortunately, I don't know the answer. The only thing I can say is if you look at a recent publication gosh, and the name is escaping me. This by Sonia Brentias. Yeah, she actually writes about curricula, and a figure that two of the people that, well, three people that figure prominently are Quṭb al-Dīn Shīrāzī and Nasiruddin Tusi, especially his Tazkira, his memoir, as a teaching text, and also Abhari is considered as an important author. So even though I can't really answer the question, I know that research on that topic is beginning to bear fruit.
Thank you very much. So one question is asking, why did the Islamic thinking insist on circular motion? Did the circular motions had any significance on the Islamic thinking?
Another excellent question. The reason for this theory that objects moved in circular orbits in the celestial realm is due to Aristotle. And you can see, I mean, that's one of his, Aristotle's, in several of his compositions, he makes a huge distinction between the sublunar realm and the celestial realm. And that's one of the big distinctions. In the sublunar realm, objects move in straight lines. You know, if you drop a stone, it goes straight to the center of the universe. Or if I suppose if you release a sack with hot air, it's going to rise straight radially outward. So that was one of the big distinctions that Aristotle proposed as far as the sublunar realm and the celestial realm. In the celestial realm, everything was assumed to move in circular motion. And we can see observationally this makes sense, because if you look at the fixed stars that they orbit, their orbits are circular. So clearly it matches the observation for the fixed stars. You know, the planets are more complicated because, of course, the universe in Shirazi's time, during the Islamic era, was geocentric. And we know these planets are not actually spinning around the Earth, but they're spinning around the sun. So in order to be able to model their motions, you know, Ptolemy had to come up with these ingenious devices. There was one more thought regarding that. Circular. Yeah, it'll come to me, but that's basically, we have, this is due to Aristotle. This is due to Aristotle.
Thank you very much. I should also mention that at the beginning of the questions, they are all also thanking you for the excellent talk, but I'm factoring those parts out.
Thank you.
So the next question, which is another excellent question, is the planetary models were quite intriguing. Do the original raw data used to construct these models still exist? Would the scientists at the time share their data, or just the models in an article or book?
Yes, the data. So this is another excellent question. The text that we've looked at, the Shirazi text, this is something known as the Heya genre, where you sort of look at these planetary motions, and this is just one of the many genres of astronomical writing. So there were extensive astronomical tables, for instance. There were extensive, these are known as Zij. So the Zij literature has barely been studied. You know, there's work, of course, work has started on it, but Shirazi himself published a very well-known Zij with data, with the motion of the planets, you know, versus basically tables of position versus time, and other parameters of these Ptolemaic formulations. And this is, of course, the Zij il-Khani. But if you look at publications on the Zij literature, there are hundreds of Zijs where working astronomers were compiling their observations in tabular form. Shirazi is not the author of a Zij. Tusi, we said, is an author of, he was a director of the Ilkhani of the Maragha Observatory, and is considered the author of the Zij. And interestingly, he acknowledges Qazvini, who we mentioned earlier, and three other preeminent astronomers. But Shirazi, even though legend has it as one of the most famous student of Tusi, doesn't appear. So this leads to its own sort of discussion of why was Shirazi snubbed? Was he in fact snubbed? I mean, so there's that whole other discussion. But yeah, the Zij literature is quite extensive. We even have the data, of course, that Ptolemy used to build his models, because they're all in his book, the Almagest.
Thank you. So the next question is, can we be sure that the changes made to a manuscript is by the original author or made by others later?
Well, this is the million-dollar question, right? The whole notion of codicology and how we interpret these changes, the marginalia. I feel really fortunate in having a copy of this Koprolu manuscript that I showed you. I got the copy, Professor Saliba generously provided that to me. But first of all, so this is always an open question. You've got to look at the manuscripts. You've got to physically look at the manuscripts, and in sort of full disclosure, I have not looked at many actual manuscript objects. I deal with digital images, and that's, I think it's the next best thing. If you can't go to the Vatican, or if you can't go to Istanbul, but if the images are available, then I think you can still say useful things about them. But in order to really definitively say who made the marks, who made the corrections, you have to probably look at the object. Again, for the Koprolu manuscript that I showed you, it's reasonably clear that this is Shirazi, and he's just fumbling around trying to come up with a working solution. And again, rather mystifying how he fumbles around so much, and how he put this in Nihāyat al-idrāk, and to some extent in Ikhtiyārāt-i muẓaffarī, and then we saw the alignment point actually continues on to the later work al-Tuhfa al-Shāfi'iyya.
So the point that you mentioned, that his writing has been unstable, is mostly related to him.
Yeah, so that's the great question, right? How can I be sure that the corrections are due to Shirazi, right? And but this we can't be sure. And in fact, I have colleagues who, whenever I show them a manuscript, they say, oh, this is a copy. This must be, it's 500 years, after what you say it is. So there's a whole science to this. I feel with this particular Nihāyat al-idrāk copy, I'm fortunate because you can almost see, the confusion of the author, and I find it really hard to believe that someone else would have plunged themselves purposely into this confusing discussion that the author is trying to make sense of.
Right. Yeah. Thank you. The next question is, could you please mention the names of scientists whose works have been notably impacted by Quṭb al-Dīn Shīrāzī's research works?
Yes, as I mentioned, so this was one of the slides, right? Many of his works survive. The names that come to mind, and that there are others, right? Because people wrote commentaries on Shirazi's work. But the two names that come to mind are Sadr al-Sharia, which I mentioned, the 14th century astronomer, and there's also, of course, Qushji, who studied Shirazi's works, and in fact, he may be the missing link. So Ali Qushji, who was the chief astronomer at the Ulugh Observatory, he relied on Shirazi's work. Now, just to mention two, it does not do justice to Tusi. There are many more, but these are two of the notable ones. So Sadr al-Sharia and Ali Qushji.
Thank you. The next question is, when was it determined that the Shirazi's model was more accurate or more optimal?
Yeah, I mean, Shirazi's lunar model was one of the earliest ones to to address these sort of Ptolemaic issues, and with Mercury as well. And this research happened in the 1960s. This was Professor Kennedy of the American University of Beirut who started looking at these texts. And again, the main interest for Professor Kennedy, and also to some extent Professor Saliba and others, is the notion of transmission, right? When did this information get to early modern Europe? As a historian of the Middle East, I'm fascinated, by these objects and by these theories, regardless of how much of it made it to Copernicus or to other authors. So the recognition of Shirazi's contribution to these planetary models started in the 1960s.
Thank you very much. We have a couple of more minutes for one or two questions. So the next question is, when great astronomers like Shirazi tried to create new astronomical models, did they really think that the universe was like that, or did they see it as a mathematical theory?
That's the tension running through the discussion, right? So Ptolemy himself, and I was hoping to find that, and I was leafing through the Almagest to include it, but he himself says, these objects are so magical. Why do we expect them to mimic the behavior that we see for objects on the Earth, right? So there was a sense in which the celestial realm was divine or semi-divine. Many held this. This goes back to the classical era, right? And we see in Tusi specifically, and Shirazi, who was a disciple, we see that they insist that if it's a sphere, it's got to behave exactly like you would expect a sphere on Earth would. So there was different schools, right? Shirazi, and I think this got him into trouble. Pardon me, this got him into trouble. He really was invested in the notion that the celestial realm was populated by physical spheres and that they behaved like any normal sphere would, or spherical shells, right? So there was a spectrum of beliefs regarding these things. But it's notable to say that Ptolemy himself recognized, well, I have to add this alignment point. I have to add the equant. I have to do all these fudge factors in order to be able to predict the observations. But who are we? We're mere mortals. The celestial realm is semi-divine, and we could maybe never hope to understand, how it is that these wheels turn in this particular fashion, how it is that the moon speeds up as it's going around in circle, this for the central of the epicycle.
Thank you. And one last question I'll ask. I would like to ask about the manuscript. Where are they mostly located? Which countries?
Thank you. When I first started my studies, it was really hard for me to obtain manuscripts. This was in 2004. I remember I think I started looking for Ikhtiyārāt-i muẓaffarī copies around 2006, perhaps. These manuscripts are often gathering dusts or they were back then, in major collections in Iran, in Turkey, and in Europe also, let's see, Berlin, Leiden. There's some in the United States, right? Thankfully, since then, many librarians have started digitizing. So really, I mean, given the language, if your language is Arabic, or if your language is Persian, or if it's Syriac, it's relatively easy to become an armchair historian. Locate the images and start studying them. There's an overabundance of documents that remain to be studied. And I think I was hoping that would be one of the themes for the talk. What Amir has done, and I just finished a work on Tusi, which is really a translation of the Moiniyeh, because an excellent edition came out in Tehran about a year and a half prior to when I published my translation. So these texts are coming out, but without the edition where you can actually read the text and read it from cover to cover, it's really hard to make conclusions. the case in point being Nihāyat al-idrāk, where in the encyclopedia, of the history of Arabic science, Saliba mentions that the lunar model belongs to al-Tuhfa. Well, that's because, if Nihāyat was fully published, if it was fully edited, then that mistake would never happen. So these texts are in collections, and researchers are starting to study them and provide modern editions, which is really what's needed in order to move the field ahead.
Thank you very much. Thank you very much, everyone. Thank you very much, Dr. Niazi, for a wonderful talk. We are 1 minute past the time. We had more questions that we had time to get to. I have a list of questions myself, but I'll ask you at a later time. Thank you, everyone.
Thank you for the opportunity.